right, ladies and gentlemen, this is an overview of our lesson from Wednesday, September 7th and Thursday, September 8th. If you'll recall, the class period before, we had started using push pull scales like the ones you see here. This is the push end, and we found out that whether we were pushing or pulling, um, the force between the contact, these two black parts, the force between the two was always the same, whether we were pulling or pushing, and whether we exerted more force on either side or whichever one was in motion, they were always the same. And so on the seventh and eighth, we decided to step it up a notch, and we attached the push pull spring scales to cars because we wanted to see, well, is this really true? Can this be true in all situations that whenever we run something into something else, that where they contact, that peak force is the same? We set it up where maybe one car was moving or both. One group changed the mass of the cars to see what happened to the force, and some groups changed the speed, increased the speed of their cars just by pushing them harder. And here's what we found out. So, first of all, you'll just notice that overall, no matter whether it was a light, medium, or heavy car, the force of the one push pull scale, so say this is A on the left and this is B, they were always almost identical. So 2.4 newtons, this should have a newton on it, by the way, versus 2.4 newtons, 2.3, 2.3. So the force of each object on the other object in contact are always the same. However, as the mass increased from a light, medium to heavy car, they added washers here, as you can see, they diagrammed. You can see that the mass went from the force of the light cars when they hit each other was about 2.4 newtons. Of the medium cars, the force was about 3.1 newtons. And of the heavier cars, the force was about 3.4 newtons. So you can see that although every time the force of one object on the other was always the same, the force did increase if the objects were heavier. And this was also true if only one of the objects were heavier. Some people just left one with no washers in it and added washers to one car. Some added washers to both cars. They got the same results. Then they looked at speed. And this one does have N for newtons, which is great. This should say trial 1, trial 2, trial 3 across the top. And you can see that they have a slow, medium, and fast car. Now, this person sort of didn't write down all their data. They just said that both A and B were 2.5, 2, 2, etc. But you can really see a difference here in that the force really increased dramatically as the speed increased. So it went from 2.1 to 3.2 to almost 6.7 newtons, which makes sense. We know that if a car is going faster, that it's going to hit with more force if it collides with something. But again, by them writing both here, this person is saying the force of A on B of the two objects is the same. And so this would be whether this one was going fast, and this could even have been standing still. The force of one object on the other is always the same. And then we just kind of wrote a brief summary of that. Hold on for just a second. Maybe I can find where I've written it down. And we just wrote that as speed or mass increase. As speed or mass increase, force increases. But the force between the two objects is always equal. And then we added to that actually that, and the direction is opposite the direction of the force.